Peak District, UK is famous of being a popular tourist destination for nature lovers. Beautiful peaks scattered with peaceful pastures. Looking at the harmonious landscape, it's hard to imagine that once this place was one of the most important mining areas of the British Empire. The mining at Ecton Hill started about 3,500 years ago in the Bronze Age and reached its peak during the second half of the 18th century. At that time, the Deep Ecton mine was the deepest mine in England. Therefore, many pioneering industrial methods were applied here to optimize the copper ore extraction. State-of-the-art technology is still needed here. In this case, not for mining ore, but to find out how it was done centuries ago. Most of the old workings are now underwater, and the only option to reveal their secrets is to use advanced underwater robots. Our detective work has started 3 years ago when the UX-1 robot explored the upper parts of the submerged passages. Now the UNEXUP team is back with their new robot, the UX-1 Neo, to dive deeper into history. The Ecton Mine Study Center once again serves as control room for the operation on the surface. The first dive site, the Great Shaft in the engine chamber, is a familiar place for an easy start. The UX-1 Neo is not just an upgraded version of the previous robot, but a new concept. Besides the elevated number of sensors, the real change is the open frame approach, where all the instruments are separately connected to the main computer, therefore the robot can easily be tailored to the given task. Right now, the main goal is to gather as much information on the physical structure of the workings as possible. The first dive went smoothly, and the team explored the shaft as far as it's possible. The next dive site, the winding shaft, is just a few meters away, but it promises longer dive, as it's allegedly a good entry point to the deeper parts. This has been a site of interest for various examinations, including depth measurements done by simply lowering weights on a fishing line. A broken fishing line is something that's really hard to detect by any kind of divers, including robots. In the control room, the operators realize that it doesn't matter how hard they've been trying to avoid the lines, the robot is entangled and needs rescue. One thing is certainly good about old fishing lines. They're not durable, so the robot can be pulled back to the surface easily. It appears that the damage is more severe than expected. The winding shaft is true to its name, as the thrusters have winded up several meters of line and become blocked. Thanks to the modularity, it's relatively easy to dismantle, repair and test the thrusters on the site, so after a short technical break, the dive can be resumed. The scanning sonars and the multi-beam sonar provide images of the environment with centimeter-level precision, even in the case of bad visibility. For the fine details, structured light systems can be used with millimeter accuracy. The real textures and colors of the walls can be revealed by camera footages illuminated with different wavelengths. The raw information is already a great help for the scientist trying to understand how Ecton Mine was operated. But the story does not end here. The 3D model allows precise volumetric calculations, further refining our knowledge on the geology of the area and on the true extent of the mining activities igniting the Industrial Revolution.